How do you see the relationship between 5G and edge computing? And why is that combination important for private networks particularly?
5G is now powering, enabling multiple use cases, right from entertainment industry to the industrial use cases, your regular connectivity in building and outside, and all types of telecom networks give you different flavors of connectivity. And now 5G is again going to the space with the NTN or the non-terrestrial network. But edge computing and the ability to co-locate the processing of the data. We talked about how both high volume data and low latency data can be enabled by 5G. The concerns about confidentiality of the data and transferring the data, security of the data, all these are getting addressed by co-locating 5G connectivity and edge computing. So this is enabling multiple possibilities.
You've been working with Lockheed Martin's 5G mill stack. Can you explain how edge computing on this platform allows localized data processing and smart control?
Lockheed has been our partner for several years, and with Lockheed Martin for the defense use cases, especially the US defense agencies, they need multiple choices of connectivity and options to form temporary or ad hoc networks. And sometimes in one of the use cases, we have enabled what is called the internet access backhaul, where we can cover difficult terrains or form temporary networks using this internet access backhaul technology. And the intelligent part of the control, we can also add what is called a RAN intelligent controller, which can coexist with the radio network. So all these sophisticated use cases, which leverage the underlying flexibility of 5G, can be enabled, and that's what we've been enabling for customers like Lockheed Martin today.
Welcome to the Tech Transform podcast, where we have a weekly conversation with people impacting the enterprise tech landscape. My name is Shubhangi Dua, the podcast host and B2B tech journalist at EM360 Tech. This episode, I am joined by Ganesh Shenbagaraman, Head of Standards, Regulatory Affairs and Ecosystems at Radisys. Today, we will discuss 5G and edge computing and how they power private networks for various industries, from manufacturing to national security and even extending connectivity to space. Welcome to the show, Ganesh. It's so great to have you on. How are you?
Doing well, and thank you for having me. And it's great to be on this podcast. Thank you, Shubhu. And this is going to be an interesting conversation.
Yes, I am sure, especially with the new advancing tech, we're just going to touch upon what is the agenda we would like to set for this episode so our audience knows what they're getting into. What is the key message you're trying to get across to them today?
Sure. And we will talk about Radis is how we are enabling 5G for multiple verticals. We've been supplying technology for more than 3 decades now, and we want to highlight a few examples of 5G, especially edge computing and 5G, how they will go well together, how we are enabling different verticals, enterprises, industrial sectors, and so on.
Okay. So, having spent years in the wireless industry, how do you see the relationship between 5G and edge computing? And why is that combination important for private networks, particularly?
It's a great question, and I would like to start with a brief introduction of what Radisys does. We have been enabling multiple OEMs, original equipment manufacturers, the telecom equipment manufacturers, and those who supply wireless networking equipment, especially the radio access network equipment. They buy our software and build their products. And we have been doing this from the early generations of wireless technology, 3GPP wireless technology, 2G as we call it, in 3G later, UMTS, and 4G, which is called LTE, and 5G, again, it's called 5G New Radio. And all these technologies and transitions, customers have stayed with us and built their products with us. And as a key enabler of this domain, we've been working very closely with our customers to build their end products. And in my role here, I've been working very closely with the customers. I have spent more than 19 years, and I've seen that slowly and steadily the industry is adopting more and more wireless technology, be 3GPP wireless technology or the cellular technology. Especially 5G becomes a great enabler for industries, enterprises, in building connectivity, and various types of use cases. Because now we are able to provide both the lowest latency and the highest bandwidth possible. At one end, you can even think of a very high quality broadcast, TV broadcast kind of live broadcast kind of thing. And the other end, it could be very small, tiny sensors talking to the network, requiring very low latency. So, this high bandwidth and low latency requirements simultaneously 5G can handle. And the low latencies which we are talking about can be very few milliseconds, and the high bandwidth could be several Mbps of data, sometimes combining at a cell level, it could be Gbps of data. So 5G is now powering, enabling multiple use cases, right from entertainment industry to the industrial use cases, your regular connectivity in building and outside, and all types of telecom networks give you different flavors of connectivity. And now 5G is again going to the space with the NTN or the non-terrestrial network, and we'll talk about it later. But edge computing, when it comes to it, and the ability to co-locate the processing of the data, we talked about how both high volume data and low latency data can be enabled by 5G. It's also important to process the data very close to the source. And 5G, with its core network architecture, allows a distributed location of the key functions of the data traffic, particular function called UPF, user plane function. If it is co-located with the radios that are serving the local network, you can get almost zero latency between the processing that happens at the wireless network and the application processing. So you can immediately process. And it also gives you the guarantee of localizing the data. The data doesn't go out of the enterprise network. So the concerns about confidentiality of the data and transferring the data, security of the data, all these are getting addressed by co-locating 5G connectivity and edge computing. So this is enabling multiple possibilities.
And how did you achieve the zero latency?
The zero latency is like co-locating the edge computing along with the user plane function. The user plane function is the last leg of the 5G network where the data exits. And if you're co-locating your edge computing application next to this UPF, or let's say on the same server, so immediately you transfer the data to the application which needs to process the data coming from the network on the devices. The devices could be sending very domain specific data. It could be manufacturing data. Let's say consider a cement manufacturing industry. The quality of the cement that is getting manufactured, you need to do almost a real time analysis. And you do a camera feed, a 5G enabled camera that gives this data over the 5G network. The user plane function immediately transfers it to the application, the edge application, where it can be processed in real time. The image analysis can happen, and they can analyze the quality of the cement that is being manufactured instantly, almost zero latency there. That's an example.
High latency and limited bandwidth also in edge computing, as we know, can create some major challenges, especially for real time applications. You did kind of just explain how you're able to overcome those challenges, but how do 5G private networks assist industries such as manufacturing, logistics, and national security, for instance, in overcoming these obstacles? If you can provide us a use case perhaps that Radisys was able to sort of help out in that area.
Sure. Yeah. The term private networks, when we say private networks, it is an exclusive network, and sometimes there is a concern about the data not leaving the premises. So we ensure the devices connect like they connect to a regular telco network, and the data transfers over the local network and can even connect to the corporate network. So that way it is called private network or a dedicated network. And this network will mimic the public network or the telco network, the everyday cell phone which you use for 5G connectivity or 4G connectivity. So likewise, the phones, like the phones, you can use the sensors and other devices. They will be 5G enabled, or they can talk through a 5G enabled gateway. A gateway could be what we call as CPE, or customer premises equipment, which is more like a modem. You can think of like a modem. a modem that connects multiple sensors, a sensor network itself through 5G. This modem is 5G enabled and it connects to the 5G network. It is dedicated for this particular application. So you can build whatever logic you want. And there will be a lot of deployment considerations. When I say deployment consideration, how exactly the data should be transferred, to which networks and sub networks it should be connected, connecting to the corporate network, and separating data at different levels, differentiating the data of high latency and low latency. Some data could be just real time monitoring data that needs to go instantly. Some of the data could be even daily reports and other things. They don't need to go on a regular basis. So you asked for some use cases right from the examples of high end manufacturing to even aspects like meat processing industry. We see and we have worked on such use cases, including some of the medical applications where the bedside devices can, both the hospital devices and the devices which you use it on the patient, let's say it could be a wristwatch kind of device or anything that is monitoring a patient, all this can talk 5G. And the data sensitivity and including the privacy of data all can be enabled. You can connect to the respective applications and the appropriate rules, policies can be set. And that way we ensure that the concerns, compliance concerns, business concerns the customers have can all be addressed. And the combination of all this ability to differentiate in latency, throughput, along with the ability to provide complete security. And I say security, the 5G technology enables a very high end of integrity and ciphering to all the signaling messages and the data that goes through so that it cannot be easily hacked. And unlike Wi-Fi technology, there could be security concerns. Here we ensure end to end right from the endpoint, which is a device, to the radio network and to the core network. And when it is transferred reliably or securely to an application, let's say over a VPN to a corporate network, all of this can be done seamlessly by enabling a 5G private network. Hope that answers your question.
Yes, but I wonder about the companies that find it very hard to implement a new infrastructure in their systems, especially when it comes to edge computing and now HSM's going more digital, I suppose, if that's the right phrasing for it. So, how do you suggest enterprises make their software compatible with various hardware platforms from silicon providers? Basically, we want to know how to make it easier to implement a distributed 5G edge solution.
Very good question again. And one of the things which we have adopted as a company, in addition to the 3GPP standards, which is the universal standards, we also adopt or adhere to the Open RAN standards, the ORAN Alliance, which is specifying multiple specifications to provide openness in the interface and the ability to use different hardware. When I say different hardware, different silicon platforms. It could be Intel platform, Qualcomm platform, or an NVIDIA platform. And in each of this family of hardware SKUs or the BOM, the different types of servers and other inventory which is available, you get different capabilities which may make sense in one particular deployment. Let's say in some cases you need an AI, artificial intelligence capability. You might want to choose the NVIDIA platform and some of the underlying or the built-in capabilities of a GPU and so on. And in some other cases, it could be an extremely constrained platform where it is power restrained. It could be power over Ethernet for that device or that network. So in that case, we can give a small cell solution or a chipset which is low power. It could be a Qualcomm chipset. So we have the ability to deliver our software. It is already ported, integrated, and benchmarked on all these platforms. So we give the customers ready-made solution. The software we give is already deployed on all these platforms in different use cases. So the customers who buy the software from us, they don't have to worry about it. And especially the enterprises, when it comes to their concerns, they want to make sure that it is coming at an appropriate price point, the total cost of ownership, and their ability to trust the vendors or the, let's say, the provider of the hardware, right? So when we provide wide support to different vendors and chipset vendors and so on, So it gives the guarantee and the choice to our customers and enterprise customers. They can choose a vendor or a platform of their choice, what are their organization typically chooses, and including even the servers, right? And it could be a choice of a Dell server or a HP server, or it could be even a cloud platform. And our RAN software today, the Radio Network Access software and the core network software, the complete 5G suite from Radisys is cloud enabled. It could be on a private cloud or a public cloud. You can run it on an AWS or a Google Cloud, or it could be a Wind River or a Red Hat. These are our partners with whom we worked extensively to enable our software. So hosting it on a cloud, in a private cloud or a public cloud infrastructure, that's also a possibility, or I would say a guarantee, which we give. And that way, the concerns from an IT infrastructure ownership and how to lay out and deploy these devices is resolved or addressed. And we also take care of the operational aspects, the management framework, integrating with the various dashboards and everyday management, the IT support, the operation support for these things. We provide that support.
So let's talk about a use case that's already famously known.
Yeah, it's
Stack,
called Kaji Mill. It's for the military
5G
application.
mill stack. You've been working with Lockheed Martin's 5G mill stack. Can you explain how edge computing on this platform allows localized data processing and smart control?
Lockheed has been our partner for several years, and with Lockheed Martin for the defense use cases, especially the US defense agencies, they need multiple choices of connectivity and options to form temporary or ad hoc networks, and sometimes it could be permanent network. And some of these use cases necessitate a special type of connectivity from a 5G technology point of view. In one of the use cases, we have enabled what is called the Internet Access Backhaul, where we can cover difficult terrains or form temporary networks using this Internet Access Backhaul technology. And we have deployed that and worked together with our partners, Intel and Lockheed Martin, to enable this use case. And in some other cases, it could be a different scenario where it is not temporary, it is isolated network. It could be a aircraft hangar where there is some maintenance activity, or it could be a warehouse. And where again you have a private network kind of scenario or an isolated network, and different types of devices, let's say the aircraft mechanics working on the aircraft maintenance, they send, upload, and download data related to their day-to-day work, and it could be VPN connectivity and so on, and it could be just warehouse related connectivity, updating things in the warehouse and so on. So all these types of management and different types of connectivity at different points, it is a permanent network in this case, and it could be spread across a limited area. The limited area could be a few hundred square feet or square meters, or it could be several thousand or even hundreds of thousands of square feet. The network scales with the distributed architecture as required in the deployment area or the deployment site. And all it requires is a different types of connectivity, 5G connectivity, and which we ensure. And the intelligent part of the control, we can also add what is called a RAN intelligent controller, and which is basically another software node or a software capability which can coexist with the radio network. And we work with the vendors or our partners providing this RAN intelligent controller. So our 5G software works with these RAN intelligent controllers and the apps that sit on top of it. The cool thing with these apps is they can be tiny little apps, more like your apps on your smartphone. These are network applications or apps that sit on this RAN intelligent controller, and they can be artificial intelligence or machine learning enabled. They process the domain data and take some preventive actions, sometimes corrective actions. It could be even providing enough bandwidth for a high priority video, which you know, and you can even prioritize. Let's say this person is the commander in that group, and he needs a higher priority. So all these sophisticated use cases, which leverage the underlying flexibility of 5G, can be enabled, and that's what we've been enabling for customers like Lockheed Martin today.
It's great that you mentioned the example, a practical example about the commander accessing these smart controls. So that really puts things into perspective for us. And I think now we're nearing the end of the podcast. So, one of my last question to you would be, looking ahead, how do you see the combination of 5G satellite communication and edge computing? What opportunities do you foresee being created for providing high performance connectivity to areas that were previously hard to reach?
Sure. NTN is really expanding the scope of coverage now, and almost all the global operators, telcos, are embracing this technology. Not just the telcos, even the enterprises, because they need connectivity in different places. They need satellite connectivity as one more backup way of connecting to the internet. And so we are seeing a very broad interest and a lot of traction over the last 3 years or so for our technology, 5G technology, to be with the MTN non-terrestrial network capabilities. And here, what we are enabling is the ability to work with the satellite link, the high latencies that are inevitable in the satellite configuration. So our software, 5G software, is tuned for those latencies. We adjust for that latency, and the standards are already available. But we do our own advanced or sophisticated work in the scheduler, which is the packet scheduling, basically handling data both in the uplink and downlink direction, adjusting for this link latency or the satellite link latency. And we have the software tuned for all the three configurations or constellations, the LEO constellations, the MEO constellations, and GEO constellations. And we have customers using in all these three constellation configurations. And we have demonstrated this recently in the Mobile World Congress Barcelona show. And with these customers, we are designing the solutions. Some of it is in its early stages of deployment or testing. Some will be deployed over the next 2 years and 3 years. And we're going to see an explosion of connectivity with all these three configurations, LEO, GEO, and MEO. And our ability is to make sure that this is secure connections again. And the local processing or the edge computing, which you talked about, is to ensure there is local processing as well. And wherever we can avoid transmitting data over a long distance, we can avoid that too. But the key challenge in the satellite connectivity is to make sure that we are able to service the users both in the uplink and downlink directions, and the necessary tuning the software that is required. And we are very closely following and adopting the latest standards that are available. And we would say we are one of the first to announce this software and been able to address many of our customer requirements. And many in this space are designing their solution with our 5G software.
If you had to give like a practical example to put your futuristic 5G technology into perspective, not just the one that you launched, but if there's anything big on the line for Radisys in the next, let's say, 10 years, and if you had to tell us about it from a very practical, client centric perspective, what would it be?
What we are seeing is like in the telco networks are the generations of technology which we have seen 2G to 3G to 5G now. That evolution will continue even into 6G. We will continue to enable that. But we see a greater real role for Radisys in enabling a wider industry across many verticals, right from industrial manufacturing to defense. And defense, we see multiple possibilities for Radisys to contribute in customizing our software. Our ability or USP is the customization required for the use cases, our RAN software and phone network software. We are one of the few vendors to successfully customize and integrate on multiple hardware platforms. And we are very strongly supported by the ecosystem partners. So that way, we are seeing a key role for Radisys in enabling all these use cases. And later, when the technology becomes more available and affordable, as the 5G technology matures further and becomes more and more affordable, you will see the penetration of 5G services in sectors like education, remote education, especially, and especially in the developing countries. We already are supporting customers in regions like Africa and other parts of Asia, where they are trying to advance connectivity, 5G connectivity, through more affordable and open networks. And you will see Radis is playing a key role in that too for the broader social impact. And as 6G comes into mainstream, let's say in the next 3 years, we'll be a key player in 6G as well.
I look forward to that progress.
Thank you.
If you had to share a takeaway message for our CIOs, CTOs, and other IT decision out there who are listening to our conversation today, what would it be and why?
Sure. You can talk to Radisys and our partners. We can bring our partners to service any use case or you have for 5G private networks and edge computing. And we can work very closely with the telco operators to enable these use cases. That's what we do. So any enterprise, any vertical, if you have a need for secure and differentiated connectivity, 5G can solve it. Edge computing can be enabled, and that's what we do. And please talk to us.
Thank you so much, Ganesh, for joining us today. Also, thank you to everyone listening. We hope you took a lot away from today's podcast. For further information on what we've talked about, please head over to radisys.com. That's RADISYS.com. We'll be back next week with another episode in our podcast series. Until then, make sure you subscribe to this podcast on all major platforms and follow the conversation on our socials at EM360 Tech on X and LinkedIn. And for more great daily content, please head on over to em360tech.com.